In this topic, we'll turn your business and UX requirements into a clear high-level architecture for the eIDAS banking journey. You'll identify the key components, separate internal from external services, and sketch a simple architecture for remote onboarding and qualified e-signature. You've already built the foundations, digital identity basics, eIDAS, and the core building blocks. We then grounded everything in the bank's business goals and real user journeys. Now we'll translate that understanding into a first high-level architecture, which will later feed into deeper technical design. High-level architecture is the bridge between what we need and how we'll build it. Here, we decide which main components are required and how they interact, without yet choosing specific technologies. It turns business, UX, and regulatory inputs into a shared structural map that guides IT, security, and vendors toward implementation. Before we think about detailed integrations, we start with the big building blocks. First, the customer-facing app. This is where onboarding actually happens. Second, identity proofing and eIDAS, confirming who the person really is. Third, the qualified signature provider, creating legally binding signatures. Fourth, document and contract management. And finally, the bank's back office systems. Together, these domains define everyone involved in the remote onboarding journey. The customer-facing application is the user's entire experience of onboarding and signing. Typically a banking website or mobile app. It must feel simple and safe, while behind the scenes it coordinates registration, identity checks, data collection, consent, and calls to all required backend and trust services. Identity proofing is the process of proving a person really is who they claim to be. A bank can perform this itself, for example through document checks, biometrics, or video identification, or it can rely on an eIDAS-compatible identity provider. That provider uses national eID schemes and returns verified identity data with a defined assurance level. A qualified signature service is a specialized provider that signs documents on your behalf in a legally robust way. It holds your qualified certificate and private key in secure hardware, and only uses them after you strongly authenticate. Your system sends data to be signed, and the service returns a QES that satisfies eIDAS requirements. Document management is the backbone of trustworthy e-signatures. Contracts are generated by merging customer and product data with approved templates, so every document is consistent and up to date. They're then staged for signing, and only the intended version is sent to the QES service. After signing, both the document and its metadata are archived in a secure, auditable repository, supporting evidence, retention rules, and future legal verification. Back-office systems are what actually turn an approved application into a live banking product. Customer data flows into a master customer system, or CRM, which holds the single source of truth about the client. From there, product engines and the core banking system check eligibility, run risk and AML checks, and decide, approve, reject, or send to manual review. Once approved and signed, these systems open the account and keep it updated through internal APIs or message queues. At this stage, a key decision is what remains a core bank capability and what becomes a trust service you buy. Customer apps, core banking, and customer data normally stay in-house, where you control change and compliance. Highly specialized regulated functions, like identity proofing, eIDAS nodes, or qualified signatures, are usually sourced from expert providers. You balance regulatory burden, speed to market, your internal skills, and the surrounding vendor ecosystem. In eIDAS architectures, never confuse where data moves with where trust is placed. Customer data, attributes, and document hashes can travel through many systems, but legal reliance usually sits on just a few actors. The bank may route documents across its back office, yet it relies on the QTSP for qualified signatures and on the identity provider for verified attributes. Your diagram should make those trust anchors and their legal responsibilities absolutely explicit. When you draft your first architecture diagram, think in terms of just a few actors and flows. A customer interacts with the bank's front end, which talks to internal systems and a couple of key external services: identity proofing, eIDAS identities, and qualified signatures. Each box is a system. Each solid arrow a main data flow like identity attributes or signed PDFs. Keep labels simple and business-friendly so everyone can follow the story. You can think of this architecture as layering responsibilities. We start with the customer using a browser or app. That's the interaction surface. Behind it sit the bank's front end and internal systems, handling products, workflow, and documents. Next, we attach external trust services through APIs, identity proofing or an eIDAS ETP, and a QES provider. Finally, we trace three critical flows. Identify the user, generate and sign documents, then activate the account in back-office systems. Now we stress test the architecture against what really matters. From a business perspective, can a customer complete onboarding remotely and actually open the products we care about using only the components we've designed? From a regulatory perspective, are identity proofing and qualified signatures handled by providers that meet eIDAS and banking rules with clear trust boundaries? From a UX perspective, do users experience one coherent flow, even when we call external services? You've now mapped a complete high-level architecture that connects business goals, user journeys, and eIDAS trust services. You can identify components, define internal and external boundaries, and map trust and data flows. Keep this diagram handy. Next, we'll zoom in on identity proofing, QES, and evidence handling.